Alright folks, it has been 6 months since my last YouTube video. It's about 45 minutes long and it has 75 views. I would love to make a concise, articulate video. As promised earlier today, I wanted to show you how I sketched this Volkswagen logo. It's simple, lines and curves, but I wanted to go through the process of constraining everything and keeping it down to kind of a minimum number of dimensions. And you notice there's a fair amount of constraints, but very few dimensions. In fact, one dimension is going to control everything that goes on in this particular part file. So let's take a look. This is the completed file. This is what it looks like. It's got curve to it. I'll show you how I got there. You start simple and then we'll build that out. Also click some fillets on it, no big deal there. But some of the magic is in this little sketch here, and I should point out that I didn't just eyeball this or work off of an attached canvas, but quick Google search here of Volkswagen logo dimensions will pull up one of these charts, and it basically calls everything out proportionately, proportionate to the outer diameter. In this case, you pick your outside diameter, whether you're making a steel sign you're going to cut out on the plasma, whether you're painting the sign on the side of a building, doesn't matter. It's proportionate. You have 24 degrees, and these dimensions, now they're hard to see. This is the best resolution that jumped out at me here. But basically you have K, B, and A. And what they are is B is going to be 10% of the outer diameter, K is 8.5%, and then A, being this little gap, this little cutaway here, is 2.5% of the overall, the outer diameter. A little bit of history here, looking at the Volkswagen logo through the years, is changed a little bit. So let's look in Fusion and see how we got there. In this sketch, it's just an outer circle called out as, I got it at 3 inches right now. I want to scale it down for a project that I have. And then, well, let's draw a fresh one here. So I'll save this as VW2. Save. Start with a sketch. Z-axis facing up is the way I prefer. C for circle, and we'll tell it that it is 3 inches. Okay, and then we're going to offset by minus, and this is where it gets a little bit tricky here, but in brackets we're going to say should be D1, D1 times 0.1. So basically that's 10% of this first dimension here. So 3.3, easy to figure out. And let me make sure that was actually correct, because I did it wrong earlier. Looking at this, K. Oh, this is actually 8.5%. Easy enough. Let's pop back into Fusion and tweak that real quick. D1 times 0.085. And there we have, it was I think because I was trying to use a negative number, because that's how my initial offset came out. Now it's a positive number. Go figure. It's a little bit annoying how that happens. Sometimes it gets inverted or flipped. Every now and again you can change that. Another way to combat that, if you're having just absolute trouble dimensioning two concentric circles off of each other, is just to draw another circle and constrain it tangent. In this case, it will only be able to make a driven dimension because this is already established. Actually, we could delete this dimension here. That's a sketch solver issue. We should be able to use this number. We should be able to toggle that to a driving dimension. Okay, well that's annoying. That's a glitch in Fusion, I would say, because if this is not dimensioned and it's just offset, we should be able to drive this diameter. Okay, enough about that. The next thing I want is a couple of lines. That they cross the center point there, and it's not wanting to snap. That's not a problem. all I want to do is snap it each from each side, and then constrain this coincident to here. Oh, and here's my favorite trick here. If I want a center line to create a mirror constraint around, I pop open the origin and just grab whichever axis is vertical or horizontal respectively. Go ahead and convert that to this projected geometry, convert that to sketch geometry, and then I'll pick a symmetry constraint between this, that, and we have full control. Additionally, this line is going to be really handy for our 24 degree that we want. We want to have 24 degrees. So this is actually going to be simpler because in my other sketch I did a 24 degree and then a matched dimension at 24 degrees. In this case I just used a mirror constraint. Turn the origin back off, we don't need it. Another thing that was annoying me is that these closed faces, these closed loops, flash blue as I'm hovering the cursor over. It's not a big deal, but it annoys me, so I'll actually click these guys to where they aren't closed loops temporarily. Toggle that back. It just makes my life simpler. This actually needs to be construction geometry because they're going to be the center lines that everything sits on. So the next thing that I want to do is, let's see if we can pull up this. We're going to draw this top V and the bottom V. The pizza shape. So alpha line, it's going to be coincident to this. It's actually going to be parallel. We'll see if we can pick up that parallel constraint. It's trying to pop coincident to something that I don't want it to there, so I'll just let it be wild, and then we'll constrain it parallel here, and then go ahead and give it a symmetry constraint. Go ahead and get that out of the way. Alright, so then the dimension here, reference our resource here. If that B is 10%, we're going to use 5%. So we're going to say dimension between this and here is going to be this 3 number times 0.05. Let's see if that gives us what we want. It looks about right. So this is going to sit here, and then we can go ahead and draw alpha line again, here and here, constrain them symmetric about our projected line, and then parallel to one of these lines. And then we can also constrain that with this dimension. We can just hit dimension here. Not at all what we wanted. What happened? So we had a dimension here, but it didn't even stay attached. No idea. I've had that happen before, but I'm not sure why it happened now. So let's try again. So we can get this dimension again, and we'll click 3, this 3-inch, this base dimension, times 0.085, enter. Okay, so we're locked in here. That was weird. So Fusion has a few sketch solver issues. I think that's because I mess around in the 2D sketches a lot, and I kind of find ways to make things misbehave that probably don't for anybody else. But I try to kind of keep tabs on them and log them if I think they're really significant. Sometimes I think it's probably just about the order in which I did things. So let's see here. D for dimension from here to here. And then I'm going to call it out as being the same as this. Yeah, that's completely lost its mind. So we had a mirror command going, and it still says that it exists. We highlight this, but obviously that's not mirrored about that line. So why it was able to lose track of that without flagging an error, I don't know. Don't know if this is something to do with an update. So here we are. Okay, so this is as it sits. That, and then this is an easy one because it terminates at the center line, which we've already drawn, and it's going to be parallel to this. So that's a nice next line to establish. So we'll pop it up here, somewhere kind of random, alpha line, wherever, just so that it's not snapping to a point or an angle that we don't want. And then we'll say that this is parallel to this, and that this line is parallel to this line. And that's fully established here. Now the next thing we're going to do is execute the line command, pop it over here somewhere, and that's okay. It picked up that they end at the same point. That's fine, because they will. We'll go ahead and make sure that these are in fact parallel, and then D for dimension. And this is, go ahead and hit this 3" times 0.1, and then we'll grab this with a mirror command, mirror constraint, symmetry constraint. Okay, so we're halfway there, and I've already screwed up. Let's see here. The logo actually needs to come up here. So we need to draw this outer geometry alpha line. It's here, parallel. And we know that this is somewhere above, and I'll show you how we constrain this in a minute. This is somewhere above the center line. The next thing we want is to actually, we'll draw a line and then trim this guy. So alpha line here. Okay, we didn't pick up any constraints. T for trim. Trim this, and we try to make sure we don't lose too many constraints. It's almost impossible not to lose some. That's one of the things that the trim command will do. And it's a little bit frustrating, especially if you don't expect it. If you expect it, not as big of a deal. But the main thing is these are coincident now. Trim will do that. Wherever you trim it to, it causes it to be coincident. So this geometry is not just floating in space. So we can hit this with, I think, 2 constraints and fully define some of this geometry. Before I get too far ahead, though, I want to dimension this guy, and it's going to be the same thing as this. So we can grab another symmetry command here to there. Okay, so all these have changed color. Now the only things undefined are this inner geometry, and also this guy. This needs to be, I'll use a collinear on that. This is collinear here. And it's going to think really hard about that and then do it for us. Okay, and it almost looked like the top moved, but I think that was just the constraint being added. We'll check this out in a minute here. And then additionally, we can use that same collinear constraint from this because that angle is actually wrong. And so, yeah, a whole huge mess of constraints looks like, and it is, but just a couple of dimensions. Let's see here, and then we can also get these guys straightened out because this is still free to move here. But because of the way these are constrained, actually all I need to do is dimension here, and then re-reference our original dimension times 0.025, enter. It's still not right, sorry. Let's see what lost track here. Okay, yeah, so this gap is going to stay constant no matter where we drag it, but we're not centered up about that. Now I could draw a line and constrain center. I could dimension and say half of this dimension. What I chose to do earlier and what worked really good was just say that, hey, the top and the bottom lines, they're equal. So now they're fully defined and we're locked down. So remember, we don't have a closed loop because we converted these to construction geometry. So now we have a single closed loop, and now we have 3 individual faces. Now, on my model previously, I took the time to actually go in and draw. This was sketch geometry here, and I went ahead and drew arcs in here and around these other open areas. It's really kind of a tedious extra step, but it was nice because I was able to click one surface or the other. not something you have to do. It's really just a little bit of an OCD choice on my part. So we can leave this as it sits, and now we can hit extrude. So we've got a solid model if we select all of the correct things. And actually, the distance I want to be kind of proportional, because I don't want to just say that it's an 1/8 inch thick, because if I make a 24-inch one, maybe I don't want it to be 1/8 of an inch thick, or if I go down to one that's only an inch in diameter, I don't want that to be 1/8 of an inch thick. It may be, something proportional. So what I'll say is D1, which is our original diameter, and I'll say times 0.025, the same as the gap in the middle. That looks kind of nice and proportionate, right? That's not too bad. So that way, when we go back to our initial sketch and we change D1 around, fingers crossed here, let's say we want a 5-inch one. Everything should scale proportionately and not look too crazy. Does that look right? I don't know if that looks right. One way to find out is to go ahead and blow it way out of proportion. And if something's not linking, I had some sketch errors earlier on one that I did. Let's say 8 inches. Did I say 80 inches? I said 83 inches. Why not? You can make it 83 inches. We can make an 8-foot one if we want. So, yeah, that's all right. Stop sketch. Where do we park this thing at? Diameter-wise. 2.5 inches. That's a good nominal size. You can put that on the hood of your car. Okay, so that's cool. Flat ones are neat. Whatever. I think one of the things that I want to look at is filleting. Now, call me a terrible person, and I'm the machinist, so I can choose to have fillets on everything if I want. I can put a 30-second fillet on everything. Just window select, put it on everything. That means I can cut this guy out with a 16th thin mill. Now, the one thing I didn't do is I didn't make that parametric to the outside. I may want to keep it that way, because if I make a 1-inch one, I'm still kind of only going to want to go down to a 16th inch cutter, like a 1.5 millimeter cutter. I don't really necessarily prefer to go down to one smaller than that. So say this is sitting at 5 inches. Oh, it was calling up. When I saw the 2.5, it was a radius dimension. So let's say if I make this 2.5 inches, it's going to scale down. And our fillets are unhappy. It's because that's too much. That's half. So double was intersecting here, and it was not able to make that feature. Interestingly, 30 works because it almost turns it into a full round fillet there. See, there's only a small area. Okay, so maybe that's a case of where you would want to make a parametric fillet. So yeah, 15th thou looks good. Okay, but this is actually not what I care about. I want to turn this body off because we're not actually going to use that. What we want to do is turn the visibility of this sketch on, and then create a new sketch. Create a sketch on this plane here. And then we will go ahead and make an arc, 3-point arc from here. It's going to end at the top here. Let it snap tangent here. And then this dimension to the outside is going to be D1, but it's D1 divided by 2 because we're working off the radius here. So look at that sketch and make sure, yeah, we're good. And this is not fully defined yet because we let it snap tangent. That's good. So we want to call out this radius, and we'll if that's 3, then we'll that's close enough to D1. We'll say D1. And that way everything stays locked nice and proportionate. Then we can do L for line here. And then another L for line. And you could put this way or flat, but you'll see what I'm up to here in a second here. And then we'll repeat our arc command, 3-point arc. And I kind of default to 3-point arcs. I know there's probably cases where I should be using other arcs. Now we have our closed loop, and all that we really need to do is just make sure these guys are concentric. Okay, so that's concentric, but not what we wanted back here. So we just need to pick a thickness, and then this is a good case where we would D for dimension here. Grab this bottom area here and say that it is the same as we did our flat extrude D1 times 0.025, so 2.5% of D1. So yeah, 1/16 of an inch in this case. Stop sketch, and then we're gonna. I keep wanting to hit. I don't have a shortcut for revolve, but we're gonna select this profile, and the axis is going to be our z-axis, and then we're going to say, let's go ahead and make it a new component here. Click OK. And then we can use our original sketch. This is where it gets cool. Q for press pull, control to multi-select all these things here. We have these, grab the top one here, and then we're going to say not new body, but cut. And then the distance is just going to be all. So if we click distance all cut, we have this conical, what did you say, conical, it's a little bit, not even conical, convex shape here. And so that's how we pulled it up. But let's look at this original sketch because I don't like that. D1, let's go ahead and make it times 2. And that flattens out the curvature there. That's a little bit more realistic. Even that's still too much. Once again, window select. This is a lazy CAD guide, but the machinist will hate you when you do this. But if you're the machinist, what can you say? 15th thou. We didn't get everything. It's interesting that this one doesn't that ain't happening. Oh, I was trying to do an offset faces. Yeah, there we go. So we've just applied fillets to basically every available surface. Missed one or two. That's not as reliable of a tool as I experienced earlier. It's a little bit frustrating. In the model before, literally, I just did a window select, and it had no trouble at all grabbing every single edge, which is what I want. Good enough. Oh no, the main thing, the reason I'm actually putting these fillets on is because I want to catch these inside corners where I would have to reach with a small cutter. And with the corner radius, of course, you can just program it. You can just program it, and it'll leave whatever radius the cutter leaves. The issue is that you want to visualize that ahead of time and basically plan and say, okay, the CAD model looks good with a 1/16 diameter cutter, or 1.5 millimeter cutter, whatever you've got access to, and you can plan things ahead. In this case, that test could be a 30-second. But let me see if we just click OK to that. That's almost too small of a radius. May go in and tweak that, but anyway, enough messing around with that. That's how you get that file. That's how you get the item proportionate to Volkswagen's original sketch. The next thing I would look at is how to put that into CAM and make a cut part of it. Thanks for watching.